Convert the following complex numbers into polar form. And the first one we have is -3 plus 3i. Now it's always best to sketch when you're converting in this direction, from the rectangular to the polar. So -3 plus 3i would be about here. And of course we know this distance is 3 and this distance is 3, is a right angle just here. And therefore what we have is a right-angled isosceles triangle. That means that this angle here is pi by 4, and so the argument here is 3 pi by 4. When we want the modulus, we're going to use Pythagoras, so we've got the square root of 3 squared plus 3 squared, which is root 18, which is root 9 root 2, which is 3 root 2. So this is going to be 3 root 2 cis 3 pi by 4. Now the second one is 1 take away I root 3. So 1 across and root 3 down. That's going to make it say here, so that this distance is 1 and this distance is root 3. Now we should know our standard angles. This one here is going to be pi by 3. To work out the modulus or magnitude of the line, we're going to use Pythagoras' theorem. So we have the square root of 1 squared plus root 3 squared, which is the square root of 1 plus 3, which is a root 4, which we know is 2. Now, we know that 0 is here, and this one is pi by 2. This would be negative pi by 2. So we would count this angle as being negative pi by 3. And this would be 2 cis negative pi by 3. Now the next one we've got is just I. Now we know that I is just here, 1 unit up, and as we just discussed, this is pi by 2. So it's just cis pi by 2. As usual with algebra, we don't bother putting the 1 in front there. Now what about 5? So 5 is over here at a distance of 5, and of course the angle there is 0. So this one here is 5 cis 0, and hence cis 0 is just 1.